Okay, let's do a complete from-scratch walkthrough of problem 10. Problem 10 was very similar to the point problem from the last problem set. In part A, you're asked to create an interval class, which will let you define a new kind of interval object. And the object represents a numerical interval between a low value and a high value. Then in part B, we create a whole bunch of intervals that are just random. Then in part C, we ask the user to enter a number. And then in part D, we figure out which of those intervals actually contains the number that the user entered. So for example, in part C, if the user had entered 10, this interval does not contain the value 10 because 10 is not between 3 and 5.5. If the user had entered 4, then this interval would contain 4 because 4 is between 3 and 5.5. All right, enough talk, let's do it. So here I am. I'm going to create a new class called interval. Come on, interval. I'm going to create some fields. So my fields are going to be private. They're going to be doubles. I know they're going to be doubles because I see a 5.5 here. I'm going to call them low and high. You could call them whatever you want. I'm going to go ahead and auto-generate the constructor and the getters and the setters. So if you hit Alt-Insert in IntelliJ, this is the generate menu. So I'm going to generate the constructor from both these fields. And this is what you should have typed even if you didn't know how to generate it. I'm going to do Alt-Insert again, and I'm going to generate some, I'm going to generate both getters and setters here for both of these. And so now I've got get low, set high, set high. Okay. Cool. So now let's go ahead. So that's part A. Part A is done. Looks like this. Now let's go ahead and do part B. So I'll call this interval tester and public static void main string args. All right, so what did it say? Let's go back and look at the assignment. It says in the main method, create an array list of interval objects. Okay, so I make an array list like this. I say array list. And if I wanted an array list of strings, I would say string. If I want an array list of interval objects, I say interval in there, because whatever's inside the triangle brackets is the data type for what is in your list. And I'll call this interval list equals new array list. Oops. All right, great. And then you have to import array list because it doesn't know about that. All right, so next in the assignment, it says use a loop that loops 100 times to create 100 random interval objects whose endpoints are generated randomly between 0 and 100. Okay. What does it say? Make sure that for each interval, its left endpoint is smaller than its right endpoint. Aha. All right, so if I'm going to loop 100 times, the standard way of doing that is like this. Wow. Okay. I'm going to create a new interval object. So interval e equals, let's not call it e. Let's call it my interval equals new interval. And now I need a low and a high, right? But they need to be random. So let's generate them at random. Well, let's do the wrong thing first. So I could do this. I could say int math.random times 100, or 101, I guess. Int math.random times 101. Okay, what's bad about this? What's bad about this is my constructor inside interval here assumes that the first thing is the small value and the second thing is the large value. That is not necessarily true, though. Here, this random number might be 97, and this random number might be 3. So that violates the requirements of my constructor. So here's a thing that a lot of people did. A lot of people did something like this. They said, like, int a equals this one, and int b equals this one. And then they said, if a is larger than b, then let's construct it in this order, BA, because then B is the smaller one, right? Yeah, that makes sense. Otherwise, let's construct it interval. Otherwise, let's construct it in this order. Okay, oops, interval. All right, so that kind of works. This is definitely not my favorite solution because, like, look at how, I hope this feels ugly. This should feel ugly and bad. So here's a slightly better way to do it, and then I'll show you an even better way after that. Instead of testing with some statements here, let's do this. I know that this is supposed to be whichever one of A and B is smaller. So instead of having an if statement, let's use math.max and math.min, which you've already learned about. So math.min of A and B, and this is going to be math.max of A and B. So this is a little bit better because it doesn't require those if statements. I'm just saying give me the smaller of the two, give me the larger of the two. And so now I know that they're going to be in the right order. What's bad about this is even though I've fixed the problem for this code, somebody else could go ahead and write code that does the same bad thing. Because at the end of the day, my interval class isn't doing the checking to make sure that the first thing is low and the second thing is high. The interval class itself is just making that assumption. So let's do this. Let's just go back to assigning A and B here, which could be the wrong thing, remember? Like A could be larger than B. But let's have the interval class itself take care of this. So here inside interval, I'm going to call this A and this B. And here is where I'll say math.min AB and math.max AB. The reason this is good is because now the interval class itself is taking responsibility for making sure that it assigns the correct values to its fields. So so the interval class isn't relying on other people who use the interval class to do the right thing. It makes sure that the right thing happens. So that's kind of better design. It makes your code less fragile. And so now if we wanted to, I guess we could go ahead and put this back in the way that it was. All right, so what are we doing? All right, so I made my interval, but now I need to add them to the list, right? So let's do this. You know what? Okay, so I could say interval list.add my interval, and that would work. Or instead of that, you know, there's really no sense in assigning this to a variable that I never use except here. So let's just go ahead and put this code here directly. Let's go ahead and put that code directly there, and then I don't need this variable at all. Okay, so this is maybe a little bit nicer. All right, so I have now created 100 intervals. And if we wanted to see what those looked like, well, we might be able to do this. Let's do this as a test. Interval list.get element 0. So I'm going to print out what's the first interval. And if we run it, I see that the answer is, I can see that it's an interval because it says interval, but this is the memory address where the interval is. It doesn't actually display the interval. So I'd mentioned something called a toString method. A toString method actually lets you display objects directly. So let's actually go ahead and do that. I'm going to go inside my interval class, and here at the bottom, I'm going to make a new method that returns a string, and it's going to be called toString. And the way you should think about this is toString is like, let's convert my object to a string. And the string that it returns is how I want it to display. So I'm going to return a string where I'm going to display the low value followed by a space, or let's make a dash, and then the high value. So now that I have this, back in my interval tester, intervals.getZero is going to actually give me an interval object. Here, let's go ahead and assign it to something temporary. So interval temp equals, so I'm getting out the first interval in the list. I'm assigning it to temp. So I could say temp.toString, and that would display temp. Let's see if that works. Cool, so it seems like my first interval is the interval from 3 to 81. But the magic of toString is it's a built-in method. So if I just display the variable that contains my object, I don't even run any methods, I just say display temp, it will secretly and automatically run your toString method. Why are these numbers different? Remember, because we generate them randomly every time. So this is still working. I'm just displaying my interval. So now if we want to, let's do interval list. And if I run it now, you can see well, it's a little bit hard to look at this, but I've got an interval that goes from 15 to 62, and from 23 to 32, and from 53 to 60, and so on. So this is my list of 100 random intervals. All right, let's do part C. So in part C, excuse me, I'm going to ask the user to enter a number. So let's do response. I'm going to use JOptionPane. .show input dialog. Enter a number between 0 and 100. And then I'm going to say double.parseDouble response. Great. And then you chose the number num. And now I want to count. Wait, do I want to count or do I want to display? Let's see what it says. Loop over your blah, blah, blah. Display each interval that contains the user's point. Okay. So let's loop over all the intervals. So I equals 0. I is less than interval list dot size. I plus plus. And now let's get out an interval. So interval, my interval equals interval list dot get I. So I'm looping over the whole list. I'm getting the interval at location I out. And now I want to ask that interval. I want to say, is number inside that interval? So most people did something like this. They said, if num is bigger than their interval dot the low value, and their number is less than the interval high value, because that's like a test to see if it's in the range, right? Is it bigger than the low? Is it smaller than the high? In that case, let's system.out.println. Well, so now that I've got a toString, I can just print interval directly like this. Most people did something like this, my interval.getLow, and then they printed out the get high value and so on, but that's all a little bit clunky. So because we have the toString method, I can just do this. And then let's run it and see if it works. Oops, no thank you. So enter a number between 1 and 100. I'm going to enter the number 1. So it looks like only one interval contained the number 1. Let's choose an interval that's like closer to the middle, but like maybe not that much closer. Let's choose 10, or sorry, a value, not an interval. So if I choose 10, let's see, 4 to 80, that contains 10. 8 to 81, that contains 10. So yeah, it looks like they all contain 10. Great. Okay. Here is a very important learning for you. Just like we wanted to let the so a really important idea is that when you make a class, like an interval, this class should be responsible for everything having to do with it. So we already made sure that the class was responsible for ensuring that these inputs are interpreted in the right way. Making a toString means that we're making sure that our interval class is responsible for telling the world how should it be displayed. If I want to create a string out of my object, what should that string look like? So we're already doing that. This idea here, this is also a case where the interval class itself should implement this idea. This if statement is really testing, does the interval contain a particular value? So instead of getting out the interval's low and high value and doing the test ourselves, if we're going to write a nice interval class, really you should be able to say this. You should say my interval.contains num. And this contains should return true or false. True if the interval contains the number, false otherwise. So let's go ahead and make contains. Here I am inside my interval class. I've got a contains method, takes a double as an input, returns a Boolean. So I could say, what do I want to say? So same thing as before. If number is greater than get low and number is less than get high, then I want to return true. Otherwise, I want to return otherwise I want to return false. This works. This is good. But This is longer than it needs to be, because notice that if this if statement is true, I return true. If this if statement is false, I return false. So really, I just want to return whatever it is that that if statement evaluates to. Because whatever it evaluates to is what I was returning anyway in the if statement. So in other words, I'm going to return whether or not it's true that num is between low and high. So this now is my favorite version because it's made the tester so clean. Like now I don't have to look at ugly logic. I can just say loop over the list. If my interval contains the number, then print it. And that's so much nicer than the alternative. Actually, whoa! Actually, what's going to make this even nicer is let's use a for each loop. So interval, my interval, interval list. Ah, so beautiful. Look at how short this is. So I'm looping over the interval list. If my interval contains the number, print it. Oh, that should make you feel so good as a programmer. This is what you want to strive for. Code that is simple, straightforward, elegant, wonderful, bug-free. Very important, bug-free. Okay, I think that's the end of our problems. Cool. I hope this was helpful.